So welcome to GED in Review. My name is Brian Thomas. Um, I'm going to do some practice questions on ratio, proportion, and percent today. Um, again, these topics can get a little bit more where there's more math formulas involved. Just want to bring to your attention, I do have a YouTube channel. One Take Math is my YouTube channel. Usually if you just type it in, One Take Math without spaces, you should see a little green ninja that takes you to my YouTube channel. And Lesson 8 here, I have this GED 2021 playlist. Lesson 8 has a lot to do with ratio, proportion, percent, and this goes in a lot more detail. But today I'm just going to kind of hit some practice questions that you may come across on the GED test. So again, as we said, with word problems, there's going to be these knowns and unknowns. There's going to be this relationship that you have to figure out. In other words, what kind of formula could I use? An estimate can be used sometimes to kind of eliminate some of the answers and make an educated guess. Of course, set up and solve will help you get the right answer. And always make sure your answer makes sense in the end. So let me go ahead and begin this question. So from a total yearly budget of $360,000, the Wembley Foundation spends $30,000 on renting office space. What is the ratio of dollars spent on office space to dollars spent on other costs? So in this problem, again, if you want, feel free to pause the video and see if you can figure it out on your own, and then you can continue to play me to see if your answers compare to my answers. And again, there's more than one way to solve the problem. So again, the key is reading it slowly and making sure you understand things. So I've got this yearly budget of $360,000. So a budget is how much you get to spend for the whole year. And this foundation, they can spend $30,000. In other words, a part of it goes on renting office space. And then what is the ratio? And this is a key word, is the word ratio. That's a math word. What is the ratio of dollars spent on office space? And with ratios, there's also this word too that separates the two parts of ratio. What's to the left of the word to, spent on office space, to what's spent on other costs. So that's kind of the unknown, is this ratio spent on office space to dollars spent on other costs. Now for the GED, the easiest way to write a ratio is using what we call a fraction format, because a fraction, you can use the N over D button on the calculator, on the GED calculator, and you can type that fraction into the calculator, and the calculator will reduce it for you. Unfortunately, I don't have a GED calculator, so I have to do it another way. So again, some known information, we see that this is $360,000 is the whole budget. What also is known is $30,000 is spent on renting office space. So I see in my ratio, I need what's spent on office space, which is going to be the 30,000. That's going to be my top number. And then the catch is spent on other costs. The 360 actually is not what's spent on other costs. That's actually the whole budget. I would still have to subtract 30,000 from the 360. So 360, one moment. Okay. That always happens when you don't want it to. So again, we're trying to find this other cost. So I have to subtract this 30,000 from this 360. So 360,000, and I want to take away this 30,000. And again, I could do that on a calculator, but that math doesn't look too hard. So that's just going to be 330,000. So when we do this, the second part of the ratio is the 330,000. So what I have to do now is reduce this. And one way of reducing it without a calculator is in a ratio, the zeros, if there's a zero on the top and a zero on the bottom, you can just divide those out, because essentially what you're doing is dividing by 10. And when you divide by 10, that removes place value, or you lose zeros. So I can lose actually all the zeros. So I'm down now to this 3 over 33. 3 over this 33. So looking at the answers already, this 12 to 1, this 11 to 1 are kind of falling out of the problem. What I have now is like this 1 to 11 and 1 to 12. And I can kind of see that, if I divide the numerator and denominator both by 3, 3 goes in 3 one time, and 3 does go in 33 11 times. So I get this 1 to 11. So 1 to 11 is the fraction form of writing a ratio, but you can also use what you call a colon, which also represents a ratio. So $1 spent on office space for every $11 spent on other costs would be the simplest form of that ratio. So C would be the answer to that problem. So again, the word ratio is a signal that I'm allowed to use a fraction. The key is understanding what goes on the top of the ratio and what goes on the bottom of the ratio. On the GED test, it's easy to think this 30,000 is 360,000, and that would fall into this answer D, which is the wrong answer. So make sure you pay attention to the details, because some of the information you still may have to find. We have to find all the information, the knowns and the unknowns, to this problem, and the problem has to make sense in the end. So let's see if we can move on to the next question. So this one, just glancing at it, I see a percent. So Ziva's car is now worth $12,000. This is 60% of what she paid for it. How much did she pay for the car? So Ziva's car is now worth $12,000. This is 60% of what she paid for it. How much did she pay for the car? So again, you may have to read it several times and read it slowly. One of the things I pick up on is the question's asking how much did she pay for the car? Well, I know cars kind of depreciate. So what it's worth now is going to be smaller than what it was worth when I first bought it. So to me, already using estimates, the 7,200 doesn't make any sense, because the car, when she paid for it, had to be more than 12,000. So now I at least have an educated guess of 3 answers. Now, in doing percents, one of the ways we can do it is we have what's called the triangle model as a strategy. In the triangle model, there's 3 parts to a percent problem. There's what's called the part or the portion. There's also what's referred to as the whole amount or the base amount, or sometimes it's referred to as the initial amount, the beginning amount. And then we have what's referred to as the percent. The relationship in this is the part and the base will be related by division. So these are going to be related by division. And if you divide the part by the base, that's going to give you the percent. If you divide the part by the percent, that's going to allow you to find the base. And if you multiply the base times the percent, that's going to allow you to find the part. So in our problem, when I draw my triangle, what I got to figure out is what are the knowns and unknowns. Well, the 12,000 is actually what it's worth now, which means it's worth only part of the price that it initially was. So what we're really missing is the initial price, which would be the base price. That's what's going to be missing, is this right here. So the 12,000 must be the portion that it is worth now, the part that is worth now. And the 60% goes along with that. That 60% is what she paid for it. And that's really important. The part and the percent have to kind of go in line talking about the same thing. So the 60% is what she paid for it. And what we're looking for is, uh, how much she paid for the car. So those have to kind of match up. So this is what it's worth now is only 60% of the original price. So all that kind of starts to make sense. When I put the 60% in, though, you got to use 0.60 because the percent can be changed to a fraction or a decimal. An easiest way to remember, 60% means 60 divided by 100. And dividing by 100 means you lose 2 decimal places. If you lose 2 decimal places, that brings you over to 0.60, or just simply 0.60. So using the triangle model, this tells me to find the whole amount, the original amount, I got to divide 12,000 by 0.60. So if I do 12,000 divided by 0.60, that gives me then the 20,000. So 20,000 would be the original value of the car. So in other words, 20,000, if I do 60% of it, 60% of it is supposed to give me what my car's worth now, which is 12,000. So 60% of 20,000 should be 12,000. And remember, the word of means to multiply. So if I want to verify it, 0.60 times 12,000, I'm sorry, 20,000, that should equal then 12,000. So we kind of see this problem is making sense to us. See if we can move on to the next question here. So this next question is involving, don't look like a percent, so let's see what we have here. At a welding shop, the ratio of non-union workers, the ratio of union to non-union workers is 7:3. So there's this ratio language again that we're seeing. The ratio of union to non-union, we're seeing that going on, is 7:3. So that means for every 7 union, there's going to be 3 non-union. If there are 18 non-union workers at the shop, how many union workers are there? And again, sometimes it's easier to see this if I write these ratios as fractions. So I have 7 union to 3 non-union. So 3 union, or 7 union to 3 non-union. I'm just going to put NO in there. The problem is changing, though, is they're going to change the ratio where there are now 18 non-union. So notice how that goes on the bottom. And what we don't know is how many union workers go with that. So that's the unknown. So the ratio kind of helps us understand how to set up the problem. We can set up as a ratio. And when I set up ratios, what this also creates is what we call a proportion. If you have a ratio equal to a ratio, we call that a proportion. And in proportion math, the cross products must be equal. So when you cross multiply, I am supposed to get the same answer. If I don't, then it's not a true proportion. So as we move forward in this problem, we know that 3 times some value must equal 18 times 7. Well, I'm going to need a calculator for that. I lost my calculator. Hold on. All right, come back here, calculator. So I have to multiply this 18 times 7. And that's going to give me this 126. So what I'm trying to do is figure out, 3 times what is 126. At this point, you could just substitute these answers in. What you can also do is if you go backwards, I can actually turn this into a division problem. So using my calculator, I could find the answer by going 126 divided by 3. That gives me 42. So it's going to be 42 union workers. So some things to also pick up on is, just looking at the original ratio, there's 7 to 3. So over here, if there's 18:9, then there's got to be more than 18 that are union workers. Well, all these answers are more than 18, so that really doesn't help us a whole lot. Another thing I pick up on is, looking this direction, I can see that they increased the non-union by a factor of 6. And in fraction math, if you multiply the bottom by 6, you have to multiply the top by 6. So another thing I can also recognize is if I just multiply the 7 times the 6 by seeing this pattern, that should also lead me to this 42. So there are a couple of ways of seeing that. They increase the non-union by a factor of 6, so the union would have to also be increased by a factor of 6. So I multiply by 6. That would give me the 42 as well. So the estimate really wasn't very helpful. We have to kind of just recognize the different setups. And setting them up as fractions or ratios, if you will, that really helps us see the math come together. So that ratio is an important word in this problem. So let's move on to the next one. So Amelia earned $954 in commission on $15,900 in sales. What is her rate of commission? So again, notice it's important to kind of read this problem slowly. Let's see if we can pick up on some things. I'm seeing $950 goes with a commission on $15,900 in sales. And what is her rate of commission? And looking at these answers, I'm seeing these answers are all percentages. So what I'm filling up is that this rate is actually a commission rate, which a lot of times is represented as a percent. So what I'm seeing then again is I'm allowed to use my triangle model and see if I can piece this all together in a triangle model. So again, remember we have this part or the portion goes here. The base or the original amount goes there. And the percent goes here. And in our problem, the knowns are the commission, which is the part that I'm getting paid. So that part goes up here to that 54. And the whole amount that I sold was 15,900. I'm only getting a part of that or a portion of that. So 15,900 is the whole amount or the base amount here. And the commission is only a piece of that. And I don't know what the percent is. But this relationship tells me that if you divide the part by the base, that'll give me what the percent is. So using my calculator, I can go 954 divided by 15,900, hit enter or equals, that gives me 0.06. Now remember, that's in a decimal format, 0.06. To make it a percent, you would still have to move the decimal back 2 places to the right and stick on a percent symbol, which is going to be 6%. Because 6% means 6 out of 100, which is the same thing as 600ths. That's how that reads. Remember, this is the tenths place, this is the hundredths place, so it's actually 600ths. And that's what 6% means, is 600ths. So our answer there would end up being then 6%. That would be A. So again, some clues here are, we have some knowns, but really what helped me out is the answers were in percents. So it told me I could maybe try to use my percent model to strategize to solve this problem. So The estimate, again, really doesn't help me a whole lot here because I'm just not really good with fractions and decimals, so I have to kind of trust my setup and solving. But the answer does make sense because I'm not getting a big part of the 15,900, because 50% is something I'm familiar with. So, 15%, 15,900 is close to 16,000. 50% would mean I would get half of 16,000, and half of 16,000 would be 8,000. So I know that 50% would have gave me around 8,000. Well, 954 is nowhere near 8,000. So I'm kind of leaning towards these bottom numbers, not the 60%. And again, the math kind of leads me out to the 6%. So the next one, we have some information organized in a table. So an advertisement contains the following information. So the title is Winter Fitness Center Inventory Blowout Sale. All sales are 20% off the original price. So all sales, this probably should be an S there. All sales are 20% off the original price. So I have this equipment, treadmill, upright bike, home gym. Then I have these sale prices over here. Notice there's a lot of information. So the best thing to do is just probably go down to the question and see what information is relevant. In dollars, what is the original price of the home gym? So this tells me to zero in on just the home gym. Notice that this is the sale price. So the 3,148 is the sale price. And I'm looking for the original price. And I'm also seeing this little percent tucked away up here, 20% off. Now, some things to pick up on though is the 20% is actually the discount. They're not giving me the discount. The sale price is actually the other side of that. If you take 20% off, 100% would be the whole price. If I subtract 20% from that, if I subtract my discount from that, what that's going to give me is then this 80%. 80% is going to represent what I actually have to pay. Well, in other words, that's the sale price. So that's what's tricky about this one is the sale price does not mirror what this is talking about. This is the 20% off. What I got to understand is the 20% off represents the discount, and the sale price is actually the flip side of that. So 100% take away 20%, take off the discount would leave me then what I'm going to actually have to pay for the home gym. So the 80%. So in my triangle model, what I pick up on then is, again, I have my part here, my base has got to go here, and my percent's got to go here. Remember, the base also stands for the original amount. So when I make my triangle, the 80% would go, 0.80 would go here. The sale price would go here, the 3,148. That's the part that I'm actually paying. We don't actually know the base amount or the original amount. That would be the unknown. So this tells me to actually use division. Now, catch is I'm writing pretty messy here, so I almost have to go back to the original numbers here. So when I do my math, what I pick up on is the part divided by the 0.80, the 80%, is going to give me my original amount using my formula, my triangle model. So I'm going to have to type over that. So let's see if I can focus on that. So 3,148, 3,148, and I'm going to divide that by 0.80. That looks good. Hit equals, and I'm getting 3,935. So 3,935 would be my answer. So I'm seeing this guy over here. So again, if I want to check it, 0.80, 80% times the 3,935, the original price, that should give me my sale price of 3,148. So if I clear that off, I could double check that, 0.80 times the original price of 3,935, and that should give me that 3,148. So it does. So that's checking out. Okay. So again, since I'm not real strong with percentage math, these answers are hard to, narrow them down. So take advantage of that triangle model when you can. It can really help out with some of these percent problems. So our next question. Alibaba Travel estimates that 80% of its employees have more than 12 unused sick leave. If 140 employees have more than 12 days unused sick leave, how many employees work at the agency? So again, I can pick this up as a percent problem. So I have to identify my knowns and unknowns. And again, the relationship with percent problems, most of them can be solved using the triangle model. Part, base, and percent. On the G test, there's also another way to solve them, and that's using a proportion. So what the proportion model is, the part over the base has to equal the percent out of 100. So I can also use what's called the proportion model on the GED test. So in this problem, there's really just three pieces: part, base, and percent. Now, the way this works is, I got this 80% of its employees have 12 unused sick leaves. So that 80% we know goes over here. And the way that 80% works is you just write this as 80 over 100, because 80% means the same thing as 80 over 100. So that's how that drops into the equation. The proportion is like that. We don't actually change this one to a decimal. We leave it as 80 over 100. And then the other thing is we got this 140 employees. And then our unknown is how many employees work at the agency. Well, it looks like what's missing is the whole amount of employees, or the original amount of employees. So I don't know this part here, so we can use the letter X for that. The 140 employees is the part that actually has more than 12 unused sick days. So if I can read that and put that together, that 12 kind of goes there. So if I'm using the proportion model, I'm sorry, not 12. How many employees had more than 12 sick days? See how extra information can get you in trouble. 140 employees have more than 12 unused sick days. So that actually is 140. That 12 is kind of a misleader there, and it almost got me. So again, when you have a proportion, you are allowed to solve it by using cross multiplication. So what that leads me to then is 80 times, oops, let me give me a different color there. We don't need that orange. So 80 times some number, X, must equal 100 times 140. Well, when you multiply by 100, that just means to stick on two more zeros. So 140 and then two more zeros. So that'd be like 14,000. And so 80 times what is going to be 14,000. This is where you could actually start using these numbers in here to do that. Or you also can just kind of go backwards and use division. So I'm going to just use division. So 140 or 14,000, I should say. Make sure you just got enough zeros there. Divided by then 80. That's going to give me then 175 employees. So that's going to lead me then to C, 175. Now, another thing I can pick up on as far as an estimate goes is, 80% of the employees have more than 140. So we know that 140 is over half. So I can't really see 700 being reasonable. But these other three answers, again, would still be reasonable at this point. And again, that's where, making an educated guess can only get you down to 3 sometimes. So we can take advantage of the triangle model, or sometimes they may actually on the GED test use what's called the proportion model, since we are talking ratio, proportion, percents. Okay, this is actually the math way, and then we have these little shortcuts that we use. So this question, the price of a Hot Wheels track decreased by $25 to $20. What was the percent decrease in the price? So I'm looking for the percent decrease. So again, these problems get tricky because we want to just use the information that's in front of us. But percent decrease kind of implies we're actually looking for the decrease in the price. Well, if we went from 25 to 20, there's actually a decrease of $5. That's important to us because that's the part it actually decreased by. Okay, so I'm looking for the part decrease. The part it decreased by is actually the 5. So that's important, not the 20 and the 25, but actually the 5 is important to us to start with. So again, if I'm using the proportion model, I have the part over the base equals the percent over 100. The part is actually going to be the 5. The base is going to be the original amount, the beginning amount. So it started at 25 and went down to 20. So the original amount would be then this 25. And we don't know what the percent is, so we can call that X over then 100. And then in a proportion model, we're allowed to cross multiply to solve this problem. So 25 times X would be 25X. 5 times 100 would be 500. And then 25 times what is 500? And again, I can go backwards and use division to solve that problem. So if I go backwards, I can pull up my calculator and just go 500 divided by 25. And that's going to be 20. So X is going to equal 20. Now remember, this becomes 20 over 100. And 20 over 100 is the same thing as 20%. And 20% would be the same thing as 0.20 as well. So if you went the other direction, if you use the triangle model, the part would have been the 5, the base amount would have been the 25, and I would not have known this. So the triangle model would have said go 5 divided by 25. So if I do that, 5 divided by 25, that's going to be 0.2. Now remember, to change a decimal to a percent, you still got to move the decimal 2 places to the right. So I got to stick on a trailing 0, and that would become then 20%. That's the catch if you use the triangle model. The triangle model is actually going to give you a decimal. You still got to move the decimal 2 places to the right to put it in a percent form. So let's look at this question here. Denozo put $2,200 in a savings account for 6 months. That should be 1 year and 6 months. Got a typo. Hold on here. So it's going to be actually 1 year and 6 months. Okay. So that fixes that. So let's go back to our reading again. So Donoso put, again, $2,200 in savings account for 1 year and 6 months. If he earns simple interest at an annual rate of 8%, how much will he have in the account at the end of that time period? So this is actually a special type of percent problem. You actually can't use the triangle model here. This actually is one where you're investing or borrowing money. In this case, this is you're actually saving or investing money in a savings account. These types of problems are referred to as what we call simple interest because time's involved. On the GED test, you do have a formula sheet. On the formula sheet, let's see if I can pull that up here. So the formula sheet, if you notice down here towards the bottom of the formula sheet, there's, the top of it looks like this. You have area formulas, you got perimeter formulas, surface area, data formulas, mean and median, algebra, and tucked away down in algebra is a formula I equals PRT, where I equals interest, P equals principal, R equals the rate, and T is the time. So I have that formula that I have to transfer over to my problem. So simple interest is going to be I equals this PRT. So what happens is after a year and 6 months, you're going to have earned some interest. What I got to do is figure out what that actual interest is. Notice another key word in here, simple interest. Simple interest is going to be that clue to actually go to that formula sheet and pull up that formula. But this formula only calculates the interest. And the principal stands for the amount that's being put into the savings account. So the P is going to be that 2,200. The rate is going to be your interest rate, which is going to be that 8%. And notice that annual means a yearly rate. So that is going to be 8%. And again, if I'm using my calculator, I have to change it to a decimal. So I'm going to change it to 0.08. Because remember, you can change a percent to a decimal by moving the decimal 2 places to the left. So it gives me this 0.08. Now, the key about this is the time has to be in years. So I have 1 year, and then I have 6 months. The 6 months has to be converted into years. Well, since there's 12 months in a year, 6 months is a fraction of a year, so 6 out of 12. Well, 6 months out of 12 months is actually the same thing as a half. And a half is the same thing as 0.5. So a year and 6 months really is the same thing as 1.5 years. So that's the catch there, is doing that. Now, on the GED tests, you can leave it in the format of 6 out of 12, or well, you actually got to put the 1 there still. That would be like 1 and 6/12. So that would still be hard to put into the calculator. But remember, above the N over D button, we talked about this U N over D button that can help you type in mixed numbers if you want to. That's the hard way of doing it, but the calculator, the GED calculator, has the ability to do that. But for me, 1.5 is a lot easier to deal with, so I'm going to take advantage of my knowledge there. So to determine the interest, you're going to have 2,200, which is the principal. And since you have PRT, these are all connected by multiplication. So I'm going to use parentheses here for multiplication. So 2,200, the rate was 0.08, and the time is going to be 1.5. So when I do this, I can use my calculator to figure that out. So 2,200, that looks good, times 0.08 times 1.5. So that's going to be $264. So that's going to be the interest earned on the money is 264. Right now, they're trying to bait you with this 2,640, but that's a no-go. Because remember, you started with 2,200 to begin with. What I want to know is how much money will I have in the account, or will he have in the account at the end of the time period? So I want to know is what his balance is at the end of 1 year and 6 months. So I have to add to that the 264, and that's going to give me my total balance, which would be 2,464. 2,464. So that's actually going to be C. Okay. Again, those answers all look close together, so they don't really help us a whole lot. Some keys to pick up on, though, is sometimes the GED test is they're going to give you something in months, and you have to churn that into years. And the way you can do that is just divide by 12, and that'll turn it into years. That's kind of a hint there to watch out for. So that takes care of a simple interest. Again, that one's actually on the formula sheet. Look out for simple interest or a percent that involves time. Okay, I think this will be our last one. So in a 40-hour work week, Marcy spent 15 hours answering telephones. What is the ratio of hours spent answering telephones to the hours doing other types of work? So again, we talked about this word ratio. That tells me that I have to have this top number and this bottom number. What helps me is to organize it as this word two. What's before the word two goes on top. So what is the ratio of hours spent answering telephones? Well, she spends 15 hours answering telephones, so the 15 has to be the top number. And then two, the hours doing other types of work. Well, it's a 40-hour work week. If 15 hours are spent on telephones, the remaining work is going to be on other types of work. So again, the 40 is not going to be used. I actually got to go 40 take away 15. And 40 take away 15, well, I can subtract 10, then subtract 5, and that would get me down to what, 25? Or again, I can use a calculator there. That looks good. So actually, the other types of work is actually 25, not the 40. That's what you have to watch out for. Is some people just want to use information that is present. They're still using information that's not quite known, but can be found out by reading the question carefully. That's that reading and comprehension that comes into play. So spent answering the telephones, that's the 15. 2 tells me I'm using the fraction bar. The hours doing other types of work, which would actually be the 40 take away 15, which is the 25. Again, the GED calculator can reduce this for you. I don't have it, so I recognize that since these both end in 5, I can just divide both sides by 5. That's not too hard to do either. And so 5 goes in 15, what, 3 times, and then 5 goes in 25, 5 times. So my ratio is going to be 3 to 5, or 3/5. So that would be our answer to that one. So that's what has to happen on this GED. So notice how ratios, proportions, and percents kind of all go together. Well, that concludes this little quick review of the GED test. Take care.